astronomers at MIT and universities across Canada and the United States have detected a strange and persistent radio signal from a far-off galaxy that appears to be flashing with surprising regularity. The signal is classified as a fast radio burst or FRB, an intensely strong burst of radio waves of unknown astrophysical origin that typically last for a few milliseconds at most. However, this new signal persists for up to 3 seconds, about 1000 times longer than the average FRB. Within this window, the team detected bursts of radio waves that repeat every 0.2 seconds in a clear periodic pattern similar to a beating heart. The researchers have labeled the signal FRB 2019-1221A, and it is currently the longest lasting FRB with the clearest periodic pattern detected to date. The source of the signal lies in a distant galaxy several billion light years from Earth. Exactly what that source might be remains a mystery, though astronomers suspect the signal could emanate from either a radio pulsar or a magnetar, both of which are types of neutron stars, extremely dense, rapidly spinning, collapsed cores of giant stars. The team hopes to detect more periodic signals from this source, which could then be used as an astrophysical clock. For instance, the frequency of the burst and how they change as the source moves away from Earth could be used to measure the rate at which the universe is expanding. The discovery is reported in the journal Nature and is authored by members of the CHIME FRB collaboration. Since the first FRB was discovered in the year 2007, hundreds of similar radio flashes have been detected across the universe, most recently by the Canadian Hydrogen Intensity Mapping Experiment or CHIME, an interferometric radio telescope consisting of 4 large parabolic reflectors that is located at the Dominion Radio Astrophysical Observatory in British Columbia, Canada. CHIME continuously observes the sky as the Earth rotates and is designed to pick up radio waves emitted by hydrogen in the very earliest stages of the universe. The telescope also happens to be sensitive to fast radio bursts, and since it began observing the sky in 2018, CHIME has detected hundreds of FRBs emanating from different parts of the sky. The vast majority of FRBs observed to date are one-offs, ultra-bright bursts of radio waves that last for a few milliseconds before blinking off. Recently, researchers discovered the first periodic FRB that appeared to emit a regular pattern of radio waves. This signal consisted of a 4-day window of random bursts that then repeated every 16 days. This 16-day cycle indicated a periodic pattern of activity, though the signal of the actual radio burst was random rather than periodic. In analyzing the pattern of FRB 2019-1221A's radio bursts, the researchers found similarities with emissions from radio pulsars and magnetars in our own galaxy. Radio pulsars are neutron stars that emit beams of radio waves, appearing to pulse as the star rotates, while a similar emission is produced by magnetars due to their extreme magnetic fields. The main difference between the new signal and radio emissions from our own galactic pulsars and magnetars is that FRB 2019-1221A appears to be more than a million times brighter. The luminous flashes may originate from a distant radio pulsar or magnetar that is normally less bright as it rotates and for some unknown reason ejected a train of brilliant bursts in a rare 3-second window that CHIME was luckily positioned to catch. The astronomers hope to catch additional bursts from the periodic FRB 2019-1221A, which can help to refine their understanding of its source and of neutron stars in general.